Okay, guys. Good afternoon, everyone. So you can see my screen and start with the presentation. We're gonna have like a little description of like what we're trying to learn today, and we'll go to the demo. Actually, so today's session is building the RAG pipeline with LangChain and RAG evaluation. So let's start with the introduction, like what RAG stands for. So like RAG stands for retrieval augmented generation, as the name's abbreviation. So the simplest way to think of it is like search first, then answer. So imagine a support managers ask why customers are unhappy about this product. So a normal LLM might give generic answer, like based on what it learned long ago. But the RAG, the system first look inside our real compliant text or the document we gave it and pulls the most relevant snippets and maybe complaints about the customer, like fee or payment failure or confusing repayment schedule, like so on. And then the LLM reads those snippets and writes a clean summary, like analyst would do. And we even like show the exact snippet as a proof. Like we do that for only for like building, not when we build the real RAG system. So this helps with like three common issues, like LLM don't automatically know new updates. They might know your like internal domain language, and sometimes they confidently say something that isn't true. So RAG reduces that by grounding response in real evidence. So generally RAG like concludes scenario like LLM or ChatGPT or Gemini or other LLMs, they give you answer, right? So they are trained on the data, then they will give you that answer, not specifically to your document. But what if you have like internal document or like in our case, a complaint, a list of complaints for our customers? The LLM doesn't have that document, right? So what we're going to do is RAG will help us like embeds, chunk, and so on. Like we're gonna see that, but it will retrieve from that data from our document. Then it gives it to the LLM. Then the LLM gives us like an output ማለት ነው። So LLM ይሰጠዋል ይሄን ዶክሜንት ተጠቅምና give me an answer ብሎ ማለት ነው። So the LLM የሚረዳን እዚህ ጋር just ያንን ሰመራይዝ አድርጎና like በሰጠነው ፕሮምፕት predefined prompt መልስ ይሰጠናል ማለት ነው። So we'll see that in the future as well. So this is a concept of RAG, nothing complicated. So like what are the limitations of LLMs? So like memory constraints, LLM have a limited capacity to store and update knowledge. Their knowledge is like primarily stored as a static parameter and cannot easily be expanded or revised. So they trained once, yeah, and they trained them, so they won't have like every data, but they give you like hallucinate or they will not say like I don't know. So that's one of the limitation of LLM and lack of provenance. LLM struggle to provide insight into how they arrive at a specific answer, like making it challenging to understand the reasoning behind their response. Nowadays, the thinking like what it is thinking, like how it's fetching that information in Milo. But like the potential for hallucination, these models may generate responses that are actually incorrect or disconnected from reality. So one of the biggest issues in LLM is hallucination. Hallucination ማለት it goes like ሌላ አንሰር or ሌላ እንትን ውስጥ ይገባል loop ውስጥ ይገባና it gives you not like a good answers ማለት ነው. So that's hallucination for LLM. And the last one is lack of domain specific knowledge. So LLMs are trained for generalized tasks and lacks domain specific knowledge. They do not possess insights into a company's private data, rendering them ineffective at answering domain-specific or company-specific question accurately. So, አንደኛው ጥቅም for RAG ወደኛ ኬስ ስናመጣው, for example, if a company has internal documentation ሊኖረው ይችላል, they don't want to like go outside እንዲወጣ like የማይፈልጉት ዳታ ይኖራል, sensitive ዳታ ሊኖረው ይችላል, right? So what you're going to do, like you don't give that to an API key like OpenAI or ChatGPT like or DeepSeek like እንዲወጣ አይፈልጉም ያ ዳታ. So but they want to search as well. So this is where RAG comes in ማለት ነው. RAGs ያንን ኢንተርናል ዶክመንት ቻንክ አድርገን ኢምቤድ አድርገን ሰጥተነው ሎካሊ ዳውንሎድ ማድረግ እንችላለን። ሞዴልስ ፍሪ ሞዴልስ አሉ፣ በእነሱ ሪትሪቭ አድርጎ አንሰር እንዲሰጠ ማድረግ እንችላለን ማለት ነው። ሶ ኢንተርናል ዶክመንቴሽን ቻት ቦቶችንም መስራት እንችላለን በዚህ በራግ ሲስተም ማለት ነው። ሶ አይ ሆፕ ኢትስ ክሊር። ሶ like what are the RAG components? You guys can hear me, right?
Yes.
Okay, so the RAG components are like retriever and generator. So RAG is built like from the two, finder and writer, as you might say. So the finder is a retriever, like its job is to look through like a big set of text, like tickets, complaint narrative, facts or policies, and pull out the best matching snippet for that question. So it does this using like embeddings, which are number vectors. We'll see that as well. I think you saw that with some manage, but like we'll touch it as well when we do the demo. So it can match, for example, like refund not received. For example, if a complaint is like refund is not received, is payment reversal delayed. So even if the words are different, the generator takes like, even if the words are different, the semantic is the same, right? So search የሚያደርግልን like semantically ነው እንጂ like word by word አይደለም። So for example, like cut or like የሆነ term ብዙ methods ሊኖረው ይችላል። So this is bad, like I don't like this on different word ነው ያላቸው ግን but they have similar semantics, similar meaning አላቸው ማለት ነው። So it retrieves that with semantic search. So the generator, this is the LLM part. So which is like we said the writer. So it reads the retrieved snippet and turns them into like a clean explanation for example, like if we ask like why are customers complaining about billing, so the retriever might bring back snippets about double charge, refunds taking too long, or incorrect invoices, and so on. But the generator then summarize those themes in a few sentences or a bullet point. That will depend on your prompt አሰጣጣችሁ ነው የሚለየው። እሱ እንዲሰጥልን ለምሳሌ prompt ሌቭላችሁ like always give it like 3 bullet points answer ስጠኝ የምትሉት ከሆነ always ያኛው RAG system is gonna give you like always 3 bullet points ማለት ነው። So እሱም prompt engineering አችሁ ላይ ነው የምታስተካክሉት, but the generator will give you the summarized of what the retriever fetched ማለት ነው። So this is the component, the RAG component ማለት ነው። So this is how it works. User query ይኖራል, like retriever ይኖራል። retriever ከknowledge base which ያደርግልናል, then it gives it to the generator which is LLM. So it gives us like output ማለት ነው. So this is the basic idea of the RAG based system. Yeah, so let's see this. I think this will explain better. So from the left to right, when we see it like our source data, like imagine customer tickets. For this case, we don't keep them as like one big text. We break each ticket description into a smaller part called like chunks, as you saw that earlier. This makes searching more accurate because like each piece focuses on one idea. So next we convert every chunk. Chunking means like መከፋፈል ማለት ነው። just ምንም ሌላ እንትን የለውም, just like 500 chunk ካልን like 500 word ሳይሆን like letters ሊሆን ይችላል ስፔስም ሊሆን ይችላል characters ነው የምናደርገው ማለት ነው። so ከፋፍለን እናስቀምጠዋለን በኮንሴፕት just for the retrieving easy እንዲሆን ማለት ነው። so what else? So we store this like fingerprints in a vector database, like convert to embed እናደርገዋለን። embedding means like vector database, like vector style እናስቀምጠዋለን with ብዙ dimension ያለው numbers የሆነ database ነው። so we'll see that as well, but like it converts to embedding. Then the embedding has a great link between source and data and embedding አለው metadata ይኖረዋል። ከየትኛው እንደሚያመጣለን ለምሳሌ ማን ምን አይነት ፕሮዳክት ነው እንደዚህ አይነት ከስተመር ኮምፕሌንት ያመጣው እና የሚሉትን ኢምቤድ አናረጋቸውም እነዛን ቫልዩዎች but they will be there as a metadata. then embedding ስንጨርስ is going to go to like embedding store. this is the dbs fias and comma db, like the most used are those two offline methods. so it will store in those vector databases. Then the user asks something like, why are customers complaining about billing? So we embed that question too. Then we compare it with what's stored and pull back the top k most similar chunks. That might be 5, meaning we bring 5 pieces of evidence, and finally generator take the stage happens. So retrieve ያደርግልናል k is equal to 5 ካልነው 5 እንደሱ አይነት ሲሚላር ሴማንቲክ ያላቸውን ሰርቾች ያመጣልናል ማለት ነው። ቻንክ አድርገን ኢምቤድ አድርገናል right. so when the user asks, like it will retrieve that 5 similar answers and it gives it to the generator, which is the LLM, the writer ማለት ነው. so the writer like በእኛ በሰጠነው prompt, predefined prompt, it will gives us the answer. so this is the whole RAG system in detail. So yeah, this is generation, the retrieving process. So the advantage of RAG, like context-aware response, improved accuracy, efficiency, and cost effectiveness. Implementing RAG can be more cost-effective than other approaches such as fine-tuning or building an entire new model. So yeah, fine-tune ልታስቡ ትችላላችሁ። why don't we fine-tune a model ልናስብ እንችላለን። our data ላይ ተጠቅሞ why don't we use that specific data train, but that's more expensive than RAG. so if we have the document, we can just embed it and use it whenever we want. so it's cheaper than fine-tuning. Versatility, like RAG can be applied to a wide range of applications. ቻትቦት ሊሆን ይችላል። ብዙ ሜቶዶችን ብዙ አፕሊኬሽኖችን መጠቀም እንችላለን። ኢንሃንስድ ዩዘር ኤክስፒሪየንስ፣ አዳፕታቢሊቲ፣ reduced data labeling, like unlike traditional approach that might require extensive data labeling effort, RAG can leverage existing data source, reducing the need for manual data labeling and annotation. Okay, so is it clear first about RAG before we go to okay. So what is LangChain? So LangChain is like a Python framework that helps us build LLM application in an organized way. So instead of writing everything from scratch, loading text, formatting prompts, calling the model, like handling the outputs, LangChain like gives us standard building blocks. So in the pandas or in the this is a framework that we use for this purpose. So for example, like it has a document object for text plus metadata, prompt template to keep instruction for our RAG system, which keeps it like consistent, and chains that connect multiple steps into one workflow. Pipeline, RAG pipeline create ለማድረግ ይጠቅመናል. So the big benefit is like structure. So your code becomes like easier to read, reuse, and expand. Especially like we move from like small project to big one. So for example, the LangChain Bansara, what if we want like chroma DB as a vector DB ነበር የተጠቀመን የነበረው መጀመሪያ ላይ, then if we want to change it to like FIAS, manually write ብናደርገው without this framework, it will change everything, every logic. But in this case, it has specifically a function that will do so. Just name changing ብላችሁ it's gonna be easy ማለት ነው change ለማድረግ. So workflow create ያደርግልናል. It's gonna be like RAG ስትሰሩ you need LangChain as an orchestrator ማለት ነው. So why we use it? Like less glue code, few custom script to connect model, retrieval and prompts, swap components easily, change vector DB or LLM. So ብዙ አይነት LLMዎች አሉ አይደል የምትጠቀሟቸው, like GPT ሊሆን ይችላል, Gemini, እነሱ high end ናቸው. but ዳውንሎድ ስታደርጉም there are multiple LLMs from Hugging Face. So what if you want to change LLM and try another like different model? So it's going to be easier using LangChain. So reusable patterns, common workflow like RAG are already supported, faster debugging, each step is clear, so it's easy to see where problem happens. So let's just simply see embedding and vector DB. So embeddings are like, I think you have seen this with Manish, but like for brief explanation. So embeddings are like how we teach the computer to understand the meaning. Instead of treating text like plain words, we convert each sentence or chunk into vector. So a list of numbers that acts like a meaningful fingerprint. So the powerful part is this is like two texts mean similar things, their vector will be close, even when the exact word are different. For example, the refund not received and money refunded late might be close in the meaning. So meaning wise, vector closer ያደርጋቸዋል እነዚህን retrieve ስናደርግ like አንድ area ላይ ነው የሚያደርጋቸው ማለት ነው. It's not so embedding ግን ስታስቡት dimension ብላችሁ አስቡት. So one ብለን ስናስቀምጥ it's one dimension. So coordinates ለምሳሌ 2D ልንገልጽ እንችላለን, right? X and Y. So this value ያለው x እዚህ ላይ ነው, y ያለው x and y ሲሆን 2 dimension, x y z ሲሆን z ሲሆን ደግሞ it's going to be like 3 dimension, right? But vector databases are like the minimum here, you can see 384 dimensional. So think of it this way, 3 dimension ምን ያህል explain እንደሚያደርግልን የሆነ ነገር retrieve ለማድረግ እንደሚጠቅመን, then vector db has like 384 embeddings, the small ones ማለት ነው. 700 ምናምን አሉ, ግን 384 dimensions ነው ያለው ማለት ነው. So it's not really ተናለም. So semantically ነው የሚያስቀምጥልን ማለት ነው. closer ያደርጋቸዋል, similar meaning ያላቸው it's gonna like save them closer to each other. So retrieve ሲያደርግ it's gonna be around that. So this is embedding. So sentence transformers, for example, paraphrase mini LM, LS3 B2 የሚባላል ብዙ አሉ. This is just smaller ones if you want to try them. All mini LM, L6 B2 የሚባል ማለት small, fast, like strong. So what is vector DB? This is the final point. So vector DB, once we create like embeddings, we need a smart place to store them, right? That's the vector database. We can't store like 380 something dimension in a normal database. So there are like vector databases specifically designed for this one. So think of it like a search engine for like meaning instead of exact words in Dalquachuno. So it stores vector plus text chunk plus the metadata and so it enables top K retrieval. We use it because it's fast, scalable, and traceable. So vector DB mahal, for example, for this case for your project as well, Pass ልትጠቀሙ ትችላላችሁ or Chroma DB ልትጠቀሙ ትችላላችሁ ማለት ነው። So this is concepts. So is it clear? So we can go to the demo, or anything you want explanation first, or before you go to the demo? Okay, if you don't have question, let's go right into the demo. Okay, so the demo it's detailed, so I'm gonna like share you as always.
And I think there is question on chat.
Oh, okay, sorry about that. Solomon said, can RAG always be substitute of fine tuning? I mean, do they do the same stuff? Okay, that's a really good question. So not really, like substitute in your case no የሚለያየው so fine tune ማድረግ ትችላለህ for that specific domain knowledge and for specific data, but like fine tuning could be like more expensive, right? You need GPUs to train that model. Data ምን ያህል ሊሆን ይችላል? It's going to be like a lot ሊሆን ይችላል. But RAG is the simplest and easiest way. The fine tunes አታስቡ like አሁን ለምሳሌ for a company big documents ሊኖሩ ይችላሉ። እሱን ትሬን ከማድረግ RAG system ቢጠቀሙ it's going to be easier, right? Retrieve ለማድረግም it's going to read that data. Fine tuning ትችላለህ ግን it's not replacement ሳይሆን it's another way of doing it. But if you have GPU and enough in resources, yeah, you can fine tune. But if you don't, you can also use RAG. So not a way like a substitute, but another way of doing it. Okay, Salomon, I hope I answered the question. So, as I was saying, this demo has detail like end to end. I've also like added the chunk, the embedding and everything, yeah. For in order to see the RAG pipeline, you need all of it. So it's end to end, so you can read it in your own. So I can share you, but let me go over it. So for this learning objective, for this notebook only, like you're going to load and explore the customer support ticket dataset no create argan የምንሰራው, which is this one. ካግል ላይ ማግኘት ትችላላችሁ. I've put it here on the data አንድ ላይ ሼር አደርግላችኋለሁ. But this is the dataset we're working on, like customer support ticket dataset. So customer support ላይ የሚመጡት ኮምፕሌኖች like we're going to see it in this demo as well. So in this notebook, we're going to load and explore like a customer support ticket dataset, understand the data, like apply privacy safe pre-processings, create the document text field, and so on. So let's set up and import. This is just importing the data, like load the raw data. I'm not gonna spend time on this. You're already familiar with it. So there are like 8,469 tickets and 17 column data set. So there's ticket ID, customer name, email, age, and so on. So raw data contains PI means, where was it? Yeah, personality identifiable information. እነዚህ ምን ማለት ናቸው? Like username and email, phone number are sensitive, right? So ዳታችን ውስጥ ካለ like we need to remove them before we do RAG system ማለት ነው. So like raw data contains like PI, names, emails shown for exploration only ስለሆነ ነው እዚህ። So RAG system ስናደርግ we don't use like sensitive informations ማለት ነው. So it's best practice, like break አያደርገውም ሲስተሙን, but the best practice is like to leave out PI informations. So let's do the EDA, like the missing. Since you already saw the pre-processing, I'm not going to spend time here, but pre-processing is always important, as you already learned previously. So what are the ticket distributions, like ticket priority and so on. So this is just typical EDA, text length analysis. Okay, so maybe this part will help you. So text length analysis, understanding the text length helps us choose appropriate chunk size for rag. So text length ምን ያህል ነው የሚለውን አንደርስታንድ ካረግ ነው chunk size ስንመርጥ it's going to help us ማለት ነው። በጣም ሎንገር ከሆኑ chunk sizeአችንን ልንቀይረው እንችላለን። ሾርተር ከሆኑ we can like ይሄንን አይተን አይደንቲፋይ ማድረግ እንችላለን ማለት ነው። So as you can see here, the mean is 46, like the minimum is 21, the maximum is 63 words. So most description are relatively short. So median around 50 to 100 words. So word and characters are like different, guys. So when we say chunk size 500 characters, we say like word exclamation mark spacing is character, not words. So 500 means like 500 words ላይሆን ይችላል like ከ80 እስከ 120 word ሊሆን ይችላል average ማለት ነው. So it's different. It's important to understand that. So privacy safe pre-processing እንዳልኳችሁ ነው like the PII the እነሱን remove ማድረግ አለብን. First the customer name, customer email, phone number ካለው or any other sensitive information ካለው like we need to remove that before we embed. What else? Create document text field. Yes, Daraji?
Can we have different chunk sizes on any single job? I mean, using one chunk size for short sentences and the other chunk size for long sentences kind of thing?
Not really. Like we need to choose like one that can suit for all. So think of it as this way. Chunks and everything like 500 እንለዋለን እንጂ shorter ከሆነ it's gonna leave it. ምንም chunk የሚያደርገው ነገር አይኖርም። ለምሳሌ 500 character ካልደረሰ if some message or some text, it will take it as like one chunk አድርጎ ነው የሚወስደው. But አንድ row ላይ more than like 500 character ካለ it will chunk it into two ማለት. So the rest ካነሱ it's gonna like
so I have to put a threshold value, like if the character is beyond this size.
No, it will like automatically ራሱ ነው የሚያደርገው. chunk size 500 ካልከው ከ500 ካልበለጠ it will take it as like one chunk ማለት. But ከበለጠ ግን it will divide it with 500 character chunk ያደርገውና then there is called also እናየዋለን like overlap የሚባል አለ. Overlap means ለምሳሌ I don't like this data set but this is like something ብንል 500 ካራክተሩ የሆነ ቦታ ባይበቃ ከዛ like ስንት ካራክተር ወደ ኋላ ሄደን ደግሞ የዚህኛውን እንቀጥል ማለት ነው overlap እንዲያደርግ just connection እንዲፈጥርልን ማለት ነው next time አንድ አይነት ቴክስት እንደሆኑ እንድናቅና ሲሚላሪቲ እንዲኖራቸው እንድናቅ overlapንም እናስተካክላለን ማለት ነው so ይሄ ዲፋይንድ አይደለም 500 እና like overlapን you can experiment like እየጨመራችሁ አንቺ ማድረግ ትችላላችሁ ያሳነሳችሁ overlapንም እንደዛው ማለት ነው the quality ይለያያል or the different outcome ይመጣል ነው እንጂ it's not a fixed value but there is no predefined የምታደርገው ነገር የለም just chunk-ና overlap-ን ብቻ ነው define የምታደርግለት ማለት ነው so we will see that as well. Okay, so where were we? Sample document texts. Yeah. Let me show you guys. So text normalization ማድረግ አለብን before we embed. Yeah. Text normalization means points like exclamation marks or unnecessary wordዎችን normalize ማድረግ አለብን before we do the rag. So you already know like why we need pre-processing. So let's go to yeah. So after that, like we save the clean data here. So at the end, this is what it looks like. So define እናደርግና which one do we need as like embed የሚደረገው ዳታ የትኛው ነው which one is ደግሞ as a metadata የምንጠቀመው የትኛው ነው የሚለውን ለይተን ማስቀመጥ አለብን ማለት ነው so ሁለት ቦታ ሄዶ ኢምቤድ ከሚያደርግ what we did here is document text የሚባል ክሬት አደረግን ማለት ነው ኮለመን አይዲያ እንድትይዙት ነው የምነግራችሁ like so the document text subject እና description የሚሉትን ኮለመኖች አንድ ላይ አድርገን አስቀመጥንለት ማለት ነው ይሄንን ኢምቤድ እንዲያደርግ but the others they are going to be metadata ማለት ነው metadata የሚሆኑት ምንድነው for example ይሄንን chunk or ይሄንን ስንጠይቀው ወይ ከዚህኛው ሪትሪቭ ሲያደርግ አብሮ ይሄንን ሊነግረን ይችላል like ticket id 1 የሆነ ፕሮዳክት ፐርቼዙ ጎፕሮ ሂሮ የሆነ ቲኬት ታይፕ ደግሞ ቴክኒካል ኢሹ የሆነ ክሪቲካል የሆነ ቲኬት ፕራዮሪቲ ያለው ይሄንን ያመጣልን የሚለው it's just for like tracing purpose ነው የሚሆነው በሜታዳታው ማለት so once we finish the pre-processing we need to like do the chunk and embed next month so there is like the config file እነዚህ አሉ like modular ስለሆነ ማለት ነው so this is a best practice as always so share ሳረጋችሁ እነዚህ ነገሮች እንድታያቸው ነው so this is a best practice so config file ብታስቀምጡ like ለወደፊቱም ይረዳችኋል ማለት ነው so ዳታ ፋይላችሁን ዳታ ፓዛችሁን ሞዴል ኔሞች anything just ውስጥ ገብታችሁ ከምትቀያየሩ እዚህ ጋር መቀያየሩ like it's easier right for like scalable ሲሆን LLM ሞዴሉን በኋላ የምንጠቀማቸው ነው chunk size overlap 50 so config ጠርተን ከዚህ ላይ ሪድ ማድረግ እንችላለን በኋላ ማለት ነው so we don't have to just inside the code መበጥበጥ or inside the code መፈለግ አይጠበቅብንም next time like what if you want like 1000 chunks so config ፋይላችሁ እንደዚህ configurable የሆኑ like ቫልዩዎችን የምታስቀምጡበት ነው ማለት ነው so this is the config file and ሌሎችም እንዳለ አላቸው ማለት ነው evaluation docs pre-processing and so on but for this case understanding ብትረዱ ስለሆነ like we'll focus on the notebook part so in this notebook ምናየው chunking embedding and vector store save እንዴት እንደምናደርግ ማለት so what is chunking large documents need to be split into smaller pieces like embedding model have input limits typically 256 to 500 tokens smaller chunks more precise retrieval but less context and so on so we already saw that in the slide okay so we load the data here then just verifying the document text እንዳለ ማለት ነው create ያደረግነው document text እንዳለ ቼክ አደረግን እዚህ ጋር so convert to LangChain document so ቀደም እንዳልኳችሁ LangChain is a framework for RAG የሚጠቅመን like framework ነው so LangChain uses document object as a standard format የሚጠቀመው document object so what this means is page content እና metadata አንድ ላይ የያዘ ዶክመንት ነው የሚጠቀምልን ማለት ነው retrieve ሲያደርግ for feature wise document object ብሎ የሚያስባቸው page content እና metadata ነው so page content is the text that is embedded in the metadata so additional information for filtering display embed የሚደረግ information አይደለም ማለት ነው so LangChain uses this document so convert ያደርግልናል this one means እዚህ ላይ ያለ ፕሮሰሱን ማየት ትችላላችሁ like page content የሚለውን ምን እንዲመርጥልን ዲፋይን እናደርግለታለን document text የሚል ክሬት አድርገንለት ነበር right rows so page content document text የሚለው row እንዲሆንልን metadata ደግሞ እንመርጥለታለን ticket id product ticket type እነዚህን ደግሞ as a metadata ክሬት አድርግልን ብለን ዲፋይን እናደርግለታለን ማለት ነው so this is clear I hope so እኛን ዲፋይን የምናደርግለት ማለት ነው እሱን ክሊር ለማድረግ then let's see like document sample on name for example አንድ document sample ብናይ subject እና description አይደል ያስገባንለት for embed ለሚደረገው ማለት ነው so subject is product setup description I'm having an issue with the product ምናምን ሚል ኮምፕሌን አለ ማለት ነው then the metadata ደግሞ ticket id ዋናው የዚህን ነው የሚነግረን ማለት ነው ይሄ embed አይደረግም this one will but this is the information for filtering in other purposes then the first step is chunking the document so we'll split the documents into smaller chunk using recursive character text splitter split እናደርገዋለን። chunking ሜቶዱ here አለላችሁ why the chunk text and everything description ስላለ you can read it. That's ቅድም እንዳሳያችሁ config file ላይ we use like 550 overlap ማለት ነው። so 500 ወሰድን 10% overlap አድርግልን ማለት ነው። 50 is 10% of 500 right? so 10% like መሃል ላይ ቆርጠውና like overlap ነው ያደርገው ማለት ነው። Okay, so let's see like chunking parameter 550. Then let's see it's clear, right, guys? I'm not complicating things.
So we are not using semantic chunking, right?
Here, no, like we use split the document recursive characters text splitter, yeah, not semantic. It's a default LangChain የሚጠቀመው default ነው ግን ያው for each cases it's different አላቸው. For like ለዚህኛው case we used just the default one, the recursive character text splitter one. So chunking-ን complete አደረግን ጨረስን። ዶክመንቱን ሰጥተናል። ዶክመንቱ means we already defined it there. Then chunking complete, original document is the same with after chunking. So minimum length is 183, max length is 487. So ያለፈ የለም ማለት ነው technically speaking 487 ማለት ማክሲመሙ ከ500 ያለፈ የለም ማለት ነው። so ለዛ ነው chunking length እና ኦሪጂናል ዶክመንቱ እኩል የሆነው ማለት ነው። so ከ500 ካራክተር የበለጠ የለም። so እንደ አንድ ቻንክ ነው everything የወሰደው። but ቢበልጥና ብታገኙ ኖሮ chunking ሳይዙ ይለያይ ነበር ማለት ነው ከኤምቤዲንግ ጋር። so don't assume that always the same ይሆናላችሁ። then let's see sample ነው የሚለው ያው the same ማለት ከ500 ካራክተር ስላልበለጠ it's going to be the same chunking. Okay, so what else? So like create embedding in vector store is fast. Load the embedding models, all mini lim የሚባለው ሞዴል እንጠቀምና ነው embed የምናደርገው sentence transformers ስለሆኑ ማለት ነው። so embedded all chunks, convert text into vector, store in fast and persist to disk ማለት ሴቭ እናደርጋለን ማለት ነው። ፈርስት ራን ያው ሁሌ ዳውንሎድ ስለሚያደርግ ከሃጊንግ ፌዝ ላይ for this case እንድታዩት always አያስቀምጥላችሁም on this ኮምፒውተራችሁ ላይ ነው የሚያስቀምጥላችሁ on specific data path ላይ ካሹን ማለት ነው ዳውንሎድ ስታደርጉ። but for this case እንድታዩት I stored it I think where is it here. so ይሄኛው በኋላ ለምንጠቀመው ሌሊሙ ነው ፍላንቲ 5 የሚባል ሞዴል የተጠቀምነው። ይሄን እንደ ምን ብላችሁ አስቡት እንደ OpenAI or Gemini or the DeepSeek ብላችሁ አስቡት። they are just cheap smaller like ለዴሞ የምንጠቀመው ከሃጊንግ ፌዝ ላይ ያወረድነው ኦፕን ሶርስ የሆነ ሞዴል ነው ማለት ነው። ይሄኛው ደግሞ ሞዴል ትራንስፎርመሩ ለኤምቤዲንጉ የምንጠቀመው ነው። so ዳውንሎድ አድርጎ እዚህ ላይ ያስቀምጥልናል ማለት ነው። so for you guys like ቀመጥ ይችላል ግን if you predefined it the path you might see it here. So this is just telling us like where is it path config file ላይ ስላስቀመጥንለት ማለት ነው። then this will download the embedding model, embed all chunks, ቻንኮቹን ኢምቤድ ያደርግልናል ወደ ቬክተር። so yeah, this is just then after it's finished ፋያስ ላይ index.ፋያስ እና index.pickle ፋይሉን ይሰጠናል ማለት ነው። ከዚህ በኋላ ፌች ስናደርግ የምናደርገው ከዚህ we don't have to do every time embed ማድረግ አይጠበቅብንም። so every time embed የምናደርገው ምን ጊዜ ነው additional document add ስናደርግ once in a while like embed ማድረግ አለብን right? so እንዲያውቀው ማለት ነው like updated document ሲኖረን ነው የሆነ ነገር ስንጨምርበት we need to again chunk እና embed ማድረግ አለብን but የማይቀየር ከሆነ ግን we just have to fetch this index ፋይሎችን ማለት so paste እናርገው from the ከዚህ ላይ fetch እናረገው it works test retrieval እንሞክር so search result billing refund issue የሚል search result ብናረግ so it will give us like subject to refund request የሚሉትን subject እና description on embed እስካረግ ነው ድረስ so sorry okay so ቅድም subject እና description on embed ስላረግ ነው when we search billing refund issue vector ጂቪውን ያይና እንደዚህ አይነት ሴማንቲክ ቫልዩ ያላቸውን ሪተርን ያደርግልናል ማለት ነው so this is the return one ለምሳሌ subject to refund request ነው እዚህ ጋርም refund issue ነው የሚያወራው right so refund request የሚል ዲስክሪፕሽኑን አመጣለን second one also subject to refund request ነው I'm having an issue with the product purchase like please assist and so on ማለት ነው so similar complaint ያላቸውን it will bring us out ማለት ነው so እነዚህ just queryዎቹን እየጠየቅን ነው like ሶስት ስላደረግነው ነው it's nothing else then retrieval with similarity score so customer wants a refund for a damaged product ብለን query ሰጠ ነው then the result with similarity score lower score means more similar ማለት ነው so in this case lower score means vector db ላይ ተጠጋግተው ነው ያሉት ማለት ነው so ዲስታንሱን ነው የሚነግረን so lower is good ማለት ነው so ስኮሩ 0.59 means ርቀቱን ነው የሚያሳየን ከአንዱ አንዱ የሚለያይበት ማለት ነው as you can see different score ነው ያላቸው but yeah retrieve ያደርግልናል ማለት ነው ይሄ ኤልኤልኤም ጋር ምንም አልሄደም just query ነው የሰጠነው for like ጂቢዩ ላይ ብቻ ነው ሪድ እያደረገልን ያለው output እየሰጠን አይደለም summarize እያደረገልን አይደለም just giving us the raw data without the LLM the query እንደዚህ ነው የሚያወጣልን ማለት ነው just the values ነው የሚያወጣልን so what else so explore the yeah so save diagonal index እና pickle ፋይሉን save አደረግነው the file is vector index the pkl value ደግሞ ፋይሎቹንና ሜታ ዳታውን ነው የሚይዝልን ማለት ነው so already chunk እና embedding-ን ጨረስን so before we go to like building the rag pipeline do you have a question here or አንዴ ጨርሰን ጠይቃለሽ so you want so ደረጃ said like so overlap is not needed for this case አሁን ለተጠቀም ነው ከ500 ስላልበለጠ ያ but it's always better to put it there ለምን ቀደም እንዳልኩ ነው like ቴክስት ሳይዛቸው ማየታችን መጀመሪያ ፕሪ ፕሮሰሲንግ ላይ this help ያደርገናል ማለት ነው
yeah just for our case yeah I see that the length character is less than so
yeah okay so next so we already did like the pre-processing the chunking the embedding then now we need to create the pipeline the rag pipeline so we imported everything the load the vector store so since already save ስላደረግነው load ነው የምናደርገው ከዚህ በኋላ then here we need to load the LLM ማለት ነው so the LLM means እንቆይ በኋላ እናየዋለን then the LLM save ያደረግነው አለ ዳውንሎድ ያደረግነው flanty 5 የሚባል በጣም small yeah then output አይሰጠንም it's just for the demo so the better the models like the good the outcome becomes but this is for just demo ስለሆነ CPU friendly ነው እናንተ መሞከር እንድትችሉት T5 ሞዴል ነው ዳውንሎድ ያደረግነው 300 megabytes the big ones አሉ like 8 GB ምናምን አሉ እነሱ like they need GPU and more computational power so run on CPU ስለሆነ ችግር የለም እናንተ መሞከር ትችላላችሁ if you have only CPU. So we load the LLM. LLM is working, so understanding the RAG prompt. So this is what I was talking about. So RAG-ን develop ስታደርጉ promptን generate ታደርጉታላችሁ መጀመሪያ ማለት ነው. So here let me show you guys. So ምን እንደሚመልስልን we need to define it before we pass those values. So for our case, like we are telling it, you are a helpful like customer support analytics assistant. Your job is to answer question about support ticket using only the provided context, which means chunk ያደረግነው value ነው የምንሰጠው ማለት ነው. So instruction ሰጠነው, use only the information from the context below. ከኮንቴክስት እንዳትወጣ ብለን define አደረግንለት. If the context doesn't contain enough information, say I don't have enough information to answer this question ብለን define አደረግንለት። hallucinate እንዳያደርግ ማለት ነው፣ በራሱ እንዳይመልስ ኢንፎርሜሽኑ ኮንቴክስት ውስጥ ከሌለ don't answer ብለን የነገርነው። So be concise and factual, reference specific detail from the ticket when possible. So that ኮንቴክስቱን ሰጠነው ማለት ነው። Then the question means user input የሚያደርገውን it's query ማለት ነው። question አለ then answer-ን ይመልስልናል ማለት ነው ፕሮሰስ አድርጎ። So this is where you define it. So እዚህ ጋር ቀደም እንዳልነው always use 3 bullet points when you answer ካልነው always የሚሰጠን 3 bullet points ነው ማለት ነው። So more of like እንዴት ነው fine tune ቀደም እንዳልከው ነገር ሆኖ fine tuning ግን ያው ስናደርገው just for our case ነው አይደለም የሚሆነው። So for our case እንደዚህ እንዲመልስልን instruction ሰጠነው ማለት ነው for the RAG. Then yeah, so we gave it this instruction. So building the RAG pipeline, LangChain RAG pipeline create ያደርግልናል እዚህ ጋር. As you can see here, it's a lot, but yeah. The question, then the embedding, then the vector score, find similar. So questionንም embed ያደርግልናል. What you guys need to understand is query ስንሰጠው እኛ የኛን query ለምሳሌ what are the most complaints ብለን ስንሰጠው it's a question, right? Then questionን with this vector db embed ያደርግልናል። ለምሮ embed የሚያደርግልን ሲሚላሪቲ ሰርቹን እንዲያገኝልን ማለት ነው ከዳታቤዝ ውስጥ። then vector store አያስመኝ የተጠቀምነው find similar document ከውስጥ ያገኝልናል። retrieved document ያወጣልናል። then format prompt context plus question ይሰጠዋል for the LLM ማለት ነው። for the LLM ደግሞ answer plus source-ን አድርጎ ይሰጠናል ማለት ነው። So this is the whole process. But let's ask it a question. Already pipeline connect ስላደረግ ነው ማለት ነው። So retrieve k is equals to 5 ነው የሰጠነው። So 5 ቫልዩዎችን ነው የሚሰጥልን ለLLM። So እዚህ ጋር just ቫልዩ ስለተጠቀምነው LLM ማለት ያው T5 ሞዴል ማለት ነው የሚጠቀመው። Then let's see like a question እንስጠውና what are the most common billing and payment issue customer reports? ስንጠይቀው like the answer the issue I'm facing is intermediate sometimes it works fine but the other times it acts unexpectedly ምናምን so ይሄን ይሰጠናል። it's not good ያው the answers is not good ያው ሞዴሉ ላይ ዲፔንድ ስለሚያደርግ ማለት ነው but it gives us ማለት ነው ምን ተጠቀመ የሚለውን ደግሞ for this case ሜታዳታውን ይነግረናል ማለት ነው። so source 5k5 ነው የተጠቀምነው so 5 ዶክመንት ነው የተጠቀምነው ይሄን አውትፑት ለማምጣት source 1 source 2 እያለ ሁሉንም here ይነግረናል ማለት ነው። so this is the metadatas ሜታዳታውንም ከምን ላይ እንዳመጣው ቲኬት አይዲ 7433 የሚል ፕሮዳክቱ አይፎን የሆነ ታይፑ እንደዚህ ሆነ ምናምን ዲስክሪፕሽኑ ይሄ የሆነ እነዚህ አምስቱን ተጠቅሜን ይሄን አውጥቶ የሰጧችሁ ነው ብሎ የሚነግራችሁ ማለት ነው። so this is question 2 like multiple questions ላደረግንለት question 4 question 5 just different type ሆነ እንድታዩት ነው። so then examine the RAG process in detail እንደነገርኳችሁ ሌላ ነገር የለውም። so this is the step to build the RAG system. Then finally ራግ ኢቫሉዌሽን አለ። ሶ ራግ ኢቫሉዌሽኑ ኢኒሻላይዝ ራግ ፓይፕላይኑን ክሬት እናደርጋለን። ሪቪው ዘ ስኮሪንግ ጋይድስ እኛን የምናስቀምጥለት ያው ማኑዋሊ የምንሰራው ነገር ነው ይሄኛው። ሶዝ ላይክ ይሄ የሚጠቅመን ራግ ኢቫሉዌቱን የሚጠቅመን ላይክ ምን አይነት ሞዴል ብንጠቀም ሞዴል ስንቀያየር አውትፑቱን ዊዝ ሴም ኩዌሽን ሰጠነው ግሬዲንግ ብላችሁ አስቡ። ሶ ይሄንን ኢንፑት ስንሰጠው ምን አይነት አውትፑት ሰጠን፣ ከዛ ኢፍ ዊ ፊል ኢትስ ጉድ እያለን ስኮር እንሰጠዋለን ማለት ነው። ዘን ሞዴል ስንቀይር ደግሞ ዘ ሴም ኩዌሽን ሰጠነው። ሴም ኩዌሽን ሚንስ ለምሳሌ ኢቫሉዌሽን ኩዌሽኖቹ አይቀየሩም እነዚህ ለምን ዘ ሴም ቫልዩ ላይ ኢቫሉዌት እንድናደርገው ማለት ነው። ሶ ኢቫሉዌሽን ኩዌሽኖቹን እንሰጠዋለን ፎር ዲስ ሞዴል ስንጠቀም ፎር አወር ኬዝ ኢፋይፉን እንጠቀምነው ራይት። ኦፕን ኤአይ ብንጠቀምና ይሄንን ኢንፑት ብንሰጠው ኩዌሽን ብንሰጠው ምን አይነት አውትፑት ይሰጠናል የሚለውን ካየን በኋላ ማኑዋሊ ኢቫሉዌት እናደርገዋለን ማለት ነው። ጉድ ከሆነ ጉድ እዚህ ጋር ላይ ኩዌሽኑን ስንሰጠው what are the most common issues reported for smart TV ብለን ጠየቅነው። አንሰሩ the issue I'm facing is ምናምን like it's not really good right. so ይሄን ትቀንሳላችሁ። for example what problem do customer face with GoPro cameras ብለን አስካረግ ነው። and the answer is the video was shot on mobile phone ምናምን ብቻ እያየን ከኮንቴክስቱ ጋር domain wise is it good or not የሚለውን ኢቫሉዌት እናደርገዋለን ማለት ነው። so ማኑዋል ስኮሪንግ ነው። ስኮር እንሰጠዋለን 3 ከሆነ 3 5 ከሆነ ጉድ this is just so in table evaluation ስለምትሰሩ እናንተም so this is how you do it. so question አለ generated answer አለ retrieved sources አለ። ግን generated answer ያው LLM ነው የሚሰራላችሁ ማለት ነው። so you just give it question answerውን እሱ ነው generate አድርጎ የሚሰጣችሁ። evaluation ብቻ ነው manually create የምታደርጉት ማለት ነው። ከዛ ኮሜንት መጻፍ ትችላላችሁ። ለምሳሌ provide some relevant info about TV issue but ይሄንን አንሰጠም ብላችሁ ማለት ነው። so this is how you evaluate this end to end ማለት ነው። so tomorrow we're going to see how we build the chatbot using Gradio. but for today this is everything. so thank you guys. if you have any question you can ask me. I hope it's clear. Okay, thank you. I'm gonna give you 2 minutes. If you have question, you can ask. Okay, so Daraji, I've answered your questions, right?
Yes, definitely, but please one question, sorry.
Okay.
So score is a distance between vector values. Is that it?
Yes, for this case,
Yeah.
vector DView is it's complex for us to understand, like 3D ዳይሜንሽን ያለው ማለት ነው። ሶ ኢን ዳት ዳይሜንሽን ውስጥ ምን ያህል ክሎሰር ናቸው የሚለው ነው። ሁለቱ ቫልዩዎች ምን ያህል ክሎሰር ናቸው የሚለው ነው። ሶ the closer they are the smaller the value ማለት ነው። ሶ it's good ማለት ነው።
384 ዳይሜንሽን ለምሳሌ ቢኖረን 384 ቬክተር ቫልዩ አለ ማለት ነው። ስለዚህ ስኮር የምንለው የነዚህ አቨሬጅ ዲስታንስ አቨሬጅ ቫልዩ ዲስታንሱን አቨሬጅ ቫልዩ ማለት ነው።
አቨሬጅ ቫልዩን ማለት ነው። ለምሳሌ ሁለት ወርድ ቢኖረን ጉድ ኤንድ ባድ ቢኖር አም ፕሪቲ ሹር ጉድ ኤንድ ባድ አር ኦፖዚት አይደል? ስለዚህ ጥግና ጥግ ነው የሚሆኑት፣ በቃ አይገናኙም ማለት ነው። ክሎሰር አያረጋቸውም። በት ጉድ ኤንድ አይ ላቭ ዲስ ቢሆን ሴማንቲክሊ ይመሳሰላሉ ራይት?
yes
ቅርብ ያረጋቸዋል ማለት ነው። ሶ that's the distance.
good. so can you change number of layers? ለምሳሌ ኢምቤዲንግ ላይ ምን ሌየር 6 ሚላለ ሌየሩን ከፍ ማድረግ ይችላል?
ሌየሩን ሳይሆን ኢምቤዲንግ ሞዴሎቹ እዚህ ጋር ላይክ ሴንቴንስ ትራንስፎርመሮች አሉ አይደል? ለሱ ክሬት የተደረጉባቸው አሉ። ሶ ሞዴሉን ስትቀይረው ነው ሊቀየርልህ የሚችለው። So you change the model, just not the dimension. Dimension like integrated የሆነ create የተደረገ ነው። It's complex thing, but it's already defined የሆነ ነገር ነው። So ሞዴል ነው የምትቀይርለት ማለት ነው። ኤምቤድ ለማድረግ you can like use different types of models አሉ። Hugging Face ላይ ማየት ይችላል።
Okay, how about do we have guidelines for the prompt engineering? For example, my prompt may be different from other students, so I don't know. So if
Yes,
the
yeah.
prompt differs, the result is going to be different. So
Yes,
do you
yes,
have?
yeah. You're right.
So
It's going to be yes, it's going to be different for everyone. But basically, የምንፈልገው ነገር at least the basic ይኖራል, right? ለምሳሌ let me open up here. Or is it LLM? So ከኮንቴክስቱ እንዳይወጣ መንገር አለብን at least the basic one. So hallucination እንዳያመጣ ደግሞ ካላወቀው ወይ እዛ ዳታ ውስጥ ከሌለ ለምሳሌ ሌላ ጥያቄ ልንጠይቀው እንችላለን። ነው ይሄኛው ከስተመር ኮምፕሌንት ዳታን የሰጠነው right about cars or about any other things ስንጠይቀው ሄዶ ቬክተር ዲቪውን ነው የሚያየው። ቬክተር ዲቪ ውስጥ ከሌለ እና ቻንኪንጉን ማምጣት ካልቻለ አይ ዶንት ኖ ብሎ እንዲመልስ መንገር አለብን ማለት ካልሆነ ቲፒካል ኤልኤልኤም ሆነብን ማለት ነው። ሶ ከኮንቴክስት እንዳይወጣ we have to predefine it ማለት ነው። So that's the most important part. ሌላውም ያው you can experiment on it like በቡሌት ፖይንት መልስልኝ just use only one paragraph ስትመልስልኝ ማለት ትችላለህ። just answer me in one sentence ማለት ትችላለህ። ሌላው እንዳለ ነው ግን hallucinate እንዳያደርግ እና ከኮንቴክስት እንዳይወጣ you have to like define it.
Nice.
Okay.
Please, one last. If we don't clean emojis, so does it assign a vector value for emojis too while being embedding?
On the embedding part, yeah. So this is why we use like the pre-processing. So removing them is like helpful. So the cleaner the data, it's gonna be easier for the embedding and also the retrieval purposes. So just try to remove emojis and
but emojis have semantic meaning, right? So
yes, አላቸው. So we can use them as well ከፈለግን ማለት ነው for our case እነዛን ኮንቨርት የሚያደርግልን መጠቀም እንችላለን. Which I didn't experiment on, but removing them is like better የሚለው section. So RAG ሲስተሙን ዲቨሎፕ ስናደርግ ኢንፎርሜሽን እንዲነግረን ነው right የምንፈልገው just ኢሞሽኑን ሳይሆን just ኢንፎርሜሽን። ለምሳሌ ከስተመር ኮምፕሌንት ከሆነ or ዶክመንት ነው የምናስገባለት right the emojis wouldn't really help us understand that. ለምሳሌ ከስተመር ኮምፕሌንት አለ ወይ እንደዚህ ነገር ላይ አለ ወይ ስንለው ኢሞጂውን ቢያነብ ምንም ያው like are they happy sad የሚለውን ብቻ ሳይሆን ምን ነገር ያለበት ኢንፎርሜሽን ነው የሚነግረን right ኢንፎርሜሽን የሚነግረን ዶክመንት or ቴክስት መሆን አለበት። ሴማንቲክ ላይ ቢሆን yes ይረዳናል like good like laughing emoji is good like thumbs down will be bad የሚለው ግን for this case just text based ስለሚሆንና ኢንፎርሜሽን ሪትሪቭ እንዲያደርግልንና ኢንፎርሜሽን እንዲነግረን ስለሆነ I don't think emojis will help us. So yeah, removing them is better.
yes, it's crystal clear now.
Thank you, Daraji, for your question as well. So thank you guys for attending. If you have any question, you can DM me. Okay, Henok Sage, is vector process language sensitive? Yes, I think so. Yeah, it's yes, English. Like most models use English. Like Gemini ምናምን ከመጣ በኋላ አማርኛ or ሌላ ሞዴሎችን በደንብ ክሊር ያደርጋልን። So yes, for now I think it's only work on English values because like ሌላ ሞዴሎችንም እንጠቀም እንችላለን ቻንኪንግ ስናደርግ or embed ስናደርግ but if you have that specifically fine tuned የሆነ for that language የሆነ ሞዴል ካገኘን ማለት ነው. But the general ones are mostly English. Okay. Thank you guys. Have a good afternoon.